We are going to continue with this topic with AI. Which or whom from this room was actually attending last year IT Days? Anyone? Okay. Anyone saw my presentation? Okay, I have a couple of hands. Okay, so during my presentation, or before I wrote my presentation, I was tired of ripping off pictures from the web, shamelessly, right, to put them on my slides. So back then I figured that I'm going to use the new shiny toy, which was Midjourney, right? Practically, I was still stealing pictures from the web because we know that they were probably used for the training, and then all I got was a bit of processing. But ultimately, that was my first exposure to generative AI. And ever since then, right, so that was last year in November, there was an explosion of tools and systems and AIs which probably use the same, I don't know, under the scene they use the same services, or maybe they have some IP behind the scene, we don't know yet. But clearly, it's like magic happens. You just give a prompt and you get a nice picture. And to tell us a bit, more about this topic and maybe share some lights into how much is art, how much is fiction, how much is science, and how much is just, getting the right data in. I'd like to invite on stage Catalin Golban to tell us a bit more about. That was a big shout out. Catalin, stage is yours.
Thanks a lot. It's a great pleasure to be here. My topic fits very well with the presentation before, actually. So definitely to make productive systems with machine learning, we really need MLOps. In the times of generative AIs and ChatGPT and so on, I want to explain what we do in computer vision for self-driving cars and how the methods that are there in vision are very much related to the methods that are actually used in generative AI. So to set a bit the stage, we have these different levels of automated driving, and they are there for many, many years. Maybe even 10 years since I'm there in the field, and they were structured like that. It still makes sense, but now it's more and more clear that if we look at the level 5 automated driving, which means cars that are driving completely automatically everywhere in all conditions and so on, it's pretty much clear that for level 5, it's challenging to reach level 5, and it needs some new set of methods. And it needs, when I say it needs new set of methods, it's even newer and completely different paradigms that latest generative AI methods. So then the industry is still focusing on level 2 and level 3 automated driving. The difference between the two is that level 2 automated driving have a driver responsible for everything that happens, and level 3 automated driving have the system responsible for everything that happens during driving. If an accident happens, then in a level 3 system, the OEM, the system supplier are responsible and liable and so on, and not the driver. So that's the big difference. And if you look at system like traffic jam pilot assist, so traffic jam assist is the level 2 version, and traffic jam pilot is the level 3 version. And intense efforts are happening into this because those are technologies that we want to scale, in the sense of having them in all the cars that are there for consumers, and not only in some special cars, like robotaxis, like connected automated shuttles, which would fit maybe to level 4 category, but would have not that high scalability. So that being said, I can tell you that working in computer vision for level 2, level 3, level 4 even, automated driving is still interesting. And it's especially interesting given the development of AI methods that happens on a very high speed. And I tell you honestly that if you want to follow everything that happens in research in terms of AI, it's tough, and maybe you can do it without working anything else, but then what's the point? So it's really a lot of things happening. And I'm trying to connect a bit the computer vision activities with the latest AI methods and to give you some conceptual intuition on maybe how you can look at them and approach them with courage, because in the end, it is very much about software. So I was telling you about level 2 and level 3. One of the activities that is happening when transitioning from level 2 to level 3, it's to improve the availability of the systems. Means to make those systems available in new scenarios, in new situations when they were not maybe available before. So here you see some examples of capabilities, perception capabilities in rather complex scenarios. So there were some bus emerging in the current lane, some construction zone situations, all kinds of road vehicles and special vehicles where if you look at the data sets, you don't have like tens of data or tens of thousands of data. So you need special methods to approach such rare objects, for example. And this is just a few examples. So if you think carefully at what's there in the driving scenes, then it is a lot of challenges which would be corner cases, actually, for standard machine learning algorithms. And now question is how to deal with such methods. So there are some trends that are happening, and in the future, or even the cars today, they don't have one single sensors, but they have 360 sensors, and up to 10, 12, 15 cameras, depending on the system setup, that are in the car, surrounding the car, and are not only on some special cars. So this will be standard in cars that will appear in the near future. And those cars will have a central ECU, which is a powerful vehicle computer, AI-enabled, that can do this AI processing. So some of them are smaller, like pocket size. Some of them are bigger. This is one example of a vehicle computer, which is also quite heavy, and it's quite powerful. So one of the topics, for example, is how to cool those systems, because when you do computations, when you do AI inference and so on in the vehicle, there is a lot of heat dissipation. And there are also not only like coolers, like in PCs, but that's also available, but there are also different water cooling methods that are enabling to produce, to do more calculations, to dissipate more heat that happens there. So, of course, the more teraops you have for available in the car, the more power you consume and the more heat is dissipated there. One example of such perception system, so it was demonstrated by us in Las Vegas CES 2023, so beginning of the year, where you see a multitask perception network detecting all the vulnerable road users around, and maybe some special objects like traffic cones for construction zones. So this is a typical neural network architecture, transformer-based, running embedded on low-power devices that is enabling in-city vehicle or vulnerable road users detection, additionally to the free space measurements that I was showing you before with construction zones and so on. So many cameras, 360, 3D perception with state-of-the-art networks that was designed by us. So essentially, such a neural network looks like it extracts some features. So it has this encoder part, then it does some transformation, the well-known transformers with projection, spatial projection, attention modules, and so on, and then decoder, meaning decoding out of this numerical representation the actual objects in the scene there. I don't want to go into more details because I will come to details about such architectures, maybe a bit more high level in one of the later slides. So what we see that happens is that more and more parts of the traditional software code are getting transformed into neural networks trained based on data. And the data quality that is used to train those neural networks are giving the quality of the outputs. We also have a small labeling team, and I used to tell to those colleagues that whenever they do a mistake in labeling any entities in the road scenes, is like a developer making a bug in its software code, because the labeling mistakes are then reflected into the output. And then we, of course, want to apply different automation strategies, also AI-based, in order to have as clean as possible data sets. So before moving to this kind of methods, I also want to point that the continuous improvement of such methods enabling this kind of data loops with a lot of MLOps behind, by the way, this is very important. So this is one important topic in order to handle corner cases. If you train one neural network, install it in place, and then never interact with it, you can never make sure that there will always be some corner cases which needs to be handled. And if you can get and identify data from those corner cases, then you can do this retraining and software update over the air in order to improve the performance. So there is a bunch of methods, and we need more than one day to discuss about all of them. I was telling a bit about transformers. I will try to give you the intuition on how to look at different other methods, and feel free to make a picture, browse the internet. And what's important is that all those methods are interconnected, and the basic principles are the same. So what are those basic principles? When we look at a neural network, it's like a function. So it's a function that maps inputs to outputs. And this function, it's more complicated. So it's like maybe you remember from high school, function composition. It's a function that takes other function as parameters and so on. And then this function structure, it's actually depending on the neural network structure, which has different types of layers. But in the end, what they do is mapping inputs to outputs. So another view of a neural network, which is it's a good intuition of what they do actually. So taking a given input, once trained, it takes a given input, it applies this encoder based on the parameters that was trained, and you get this new representation of the input. And out of this new representation of the input, you can decode the output. So if you look at it, then if you look at the neural networks from this point of view, then this representation that they are created out of inputs is very powerful. Why? Because out of this representation, then you can imagine that you can decode multiple things. So what we actually do, we use multitask perception methods, which means we have one neural network which is solving multiple problems. And it's solving multiple problems based on a common representation. And building this common representation is hardware efficient, because you don't need to make another representation for every single task that's there, but you have a common representation for a given input, out of which you decode outputs. So this is how we do lane detection, painted symbols, pedestrians, vehicles, semantic segmentation, 3D reconstruction, and so on. So essentially, this representation is, if you look at what happens in text-based methods, large language models, and so on, generative AI, they also rely on getting large amount of text, encoding them, building a representation, and with queries out of that representation, you extract different answers. And principles are very similar, and same as we have large language models, we have large vision models, which can do similar. And one of the methods that's used to train, so you don't always have labels. So, so what I've shown you so far, it was everything supervised, means you have labels and you need to train based on labels. But we can imagine something that's called in the literature autoencoders, which so a neural network that has the task to get an image, and output the same image. So you train such a network on some known data set. You obtain a network that knows how to, given the input, to decode an output that's trained on a given data set. You have, of course, inputs and outputs because they are the same. And then this network would have the capability to reconstruct new samples. Means that in a given domain, like traffic scenarios of whatever type, this network is capable to, given an input, to reconstruct the output. Of course, if everything gets identity into this network, then it's easy. But, and then to get rid of this having identity, you need to constrain it a bit. So for example, the representation could be lower dimensional than the inputs, like a compression. And compress, decompress, but with a neural networks. So that's an idea, and what happens actually, it's you need to challenge this building the representation a bit more. So it's not enough to just reconstruct input and output, but you give it also the task to reconstruct some hidden parts of the image. So you see these yellow spots in the image, they are covered, and the network has the task to fill in the blanks. And then what you learn in this way is a representation of your data, completely unsupervised or self-supervised as a terminology, because you don't need any labels to do this. And again, when training models like GPT or BERT or this kind of language models, you do the same. So you cover some text, some words in the text, and you give the network to train, like to fill in the blanks, or to do completion. So you have some sentences, and then you have the full text, you train it with providing the next word. So that's self-supervised learning, no labels, learn out of data, and build, very important, build the representations. So then what can we do? So once having this representation, we can take it in more steps. I was showing you before the multitask perception, and we can have one of the tasks in the multitask settings that does the reconstruction, and then the next task can be supervised to detect things, but to take advantage of the previously built reconstruction. So how such a thing can be, so first of all, you pre-train in a self-supervised way, then you refine, so you do fine-tuning based on new downstream tasks. So this is like a pre-training based on self-supervised methods, and then solve your problem. Translation, for example, as equivalent to text. So translating from one language to the other, you can build a representation of different languages, but you make it common with different language inputs, and then when you translate, you extract a new meaning, or you extract out of this numerical representation a phrase in a different language. Same principle, yeah. So few-shot learning, it's another interesting method. So when you have this internal representation, maybe you can live with fewer labels data. I was showing you before the construction zone vehicles, different kind of special machines, and so on. You don't have many samples like that, but you have few, and if you have such internal representations, you can refine based on few samples and still solve your task. So few-shot learning, one-shot learning, and so on. It's methods which are fully relying on such internal representation. So this is very much simplified, oversimplified, I need to point. So the methods that build those representations for video data are many more. So you can rotate and ask the network to predict what's the rotation, or you can maybe predict, if you have video, you can predict what's the next frame in a video, and so on. So the methods, and by the way, this reconstruction task, it's called pretext task. So you have a pretext, you build a representation, and then you solve different problems after you identify this pretext task, which should match the downstream tasks that are there. So more methods, yeah, more augmentations that are possible in order to do self-supervised learning, but the idea is the same. Make a representation, and out of the representation, extract new information to solve your actual problem. That was all, yeah, from my side. Now I would like to discuss some questions with you. So hope that I managed to, in a very short time, to give you an idea of autoencoders, self-supervised learning for vision, how that's related to the text-based methods, or and actually they work for other modalities, proteins, biology, sound, and so on, multimodal, so you can train with text and video and make even more sophisticated architectures, but the main idea is the same. Have some inputs, build a representation, extract out of that.
Thank you very much.
Thanks a lot.
Catalin, really insightful. Great update, as always, so we're appreciating your presence here. Let's see if we have questions from the audience.
Yeah.
Okay. Either you're shy or you're waiting for lunch. We still have
there is one more presentation until lunch, so I thought I have the task to keep you here before lunch.
No,
with lunch
we
outside, but no,
session,
it's still
so
one more.
It's not on your shoulders. Okay, we have one question over there. Can we get the microphone, please?
Thank you for being here. So my question is, you said that the level 3
yeah.
My question is related to the level 3 self-driving cars. You said that the companies that make the level 3 driving cars would be liable if an accident happens. And how exactly would this be? So wouldn't the company want to rent the car then, rather than sell it?
I mean, I guess it's as liable as with rental or selling it. So there will be new legislation. There are initiatives on both European level and in Romania. In Romania, we were actually very much focusing on testing level 3 automated driving, and we are almost there. Yeah, let's see with government and so on. But in principle, in Romania, we are on a good track, and on a European Union, there is a framework on how to homologate, I hope it's the right English word, self-driving cars. So there will be a typical homologation process, and there will be also legislation that will regulate this. And it is in some countries. So, for example, in Germany, there are the level 3 traffic jam pilot is possible, and there are cars supporting it for like traffic jam, very well-defined situations. And yeah, so if there is some monitoring, like black box system that is monitoring what happens, was it self-driving active or not, and it's all about making rules how to specify those things.
Okay, but wouldn't it be more efficient for a company to rent the car if they are still liable than actually to sell the car to you? So you would not really own the car, you just rent the product.
I mean, it would be a new business model, definitely. So yearly we have around 80 million new cars produced globally. I think it's from units point of view, like it's more profitable to make and sell. If alternative business models to rent the cars would be established, maybe it would not be the car manufacturers, I guess, but would be some add-on services that are still buying the cars and offering it for rent, as today. So, but still, legislation would be the same for rentals or for like new cars. If I got your question correctly.
We have a couple of questions over there. Okay.
How do you use the reconstruction step in the upcoming tasks? Or why would you use self-supervision?
So if you have the reconstruction means the decoder, right?
Yes.
So decoder is neural networks layers, like convolutions or transformers or so. And you so you want to know how to make this representation as good as possible. And this is why you make it self-supervised. And then it's the reconstruction. It's like a typical decoder. It's same as the decoder in this case. In this case, simple. For semantic segmentation, it's same kind of decoding type. So you connect to different levels, different layers in the neural network, start from there and decode with standard methods what you need, like boxes, 3D boxes, lines, and so on.
So basically, by using reconstructions, you get rid of the labeling process? Human labeling process.
Okay, so I know what you mean. The reconstruction, like the block here, it's again, it's you get rid of some human labeling, or you increase performance with the same amount of labeling. And this reconstruction, it's a typical neural network layers that you would have in a UNet or a ResNet or so.
Okay,
nothing special with reconstruction.
We have 2 more questions over there. And we still have some time, so we're good.
You said you have demonstrated your technology in Las Vegas. Nice modern town, straight roads, very strict laws on jaywalking, so people only cross the road on pedestrian crossings. In England, we have one town that has got self-driving taxis. It is a new town, wide roads, very few crossroads, roundabouts, underpasses, so people do not cross the main roads. Have you tested your technology in a town like Cluj?
Yeah, definitely. I mean, some of the movies that I was showing initially are from Cluj. I can definitely see the big progress that's happening, especially using the new methods. From looking from overall system point of view, the performance it's increasing from one generation to another, from one software update to the next. This is why I say yes. We will. When it comes to scaling, so to providing the technology on an affordable level to millions of cars, industry is working between level 2 and level 3. Level 2 meaning driver still responsible for what's ahead the car, and level 3 meaning in some special, well-defined situations, like a traffic jam on the highway or driving on a highway in general. This is where we will have first like a system responsible and not driver responsible. So in Cluj, it works good, and still some challenges to solve. We are continuously collecting data, but not only from Cluj, from globally, and continuously improving our systems.
So my question was in the same direction. If you tested this, how well do these systems work on fog and country roads and stuff like that? But maybe, yeah, it was in the same direction. Maybe I ask another. So how close are we to level 4 or level 5, in your opinion?
So level 5, in my opinion, it's like you need new methods, new paradigms, and just personal opinion, and it's not something that will be solved fully with the current methods. Level 5 meaning driving absolutely everywhere. So you need it's rather equivalent to artificial general intelligence. You know that we don't have that, and we also don't have level 5 because it will always appear something. And level 4, it's something doable, and we've learned about the robotaxis, and there is also like logistics or connected shuttles and so on. The difference is that those systems have a bunch of sensors, so probably at least 6-digit cost of only the sensor part. And it's like new methods, different redundancies, different policies to be controlled remote, connectivity and so on, very well defined and restricted areas. So going in such a way to level 4, it's a complete different problem than increasing availability in city scenarios for level 2+, or for having level 3 on the highway scenarios. So level 4, doable with more expensive systems and like different business models behind.
Thank you very much, Catalin.
Thanks a lot.
You can still chase Catalin.